Alright, so we have a problem here that asks, an economist is studying the job market in the Denver area neighborhoods. Let X represent the total number of jobs in a given neighborhood, and Y represent the number of entry-level jobs in the same neighborhood. A sample of 6 Denver neighborhoods is given by the following information. Okay, so we have our X values, which are 15, 30, 50, 28, 50, and 25. These are the total number of jobs in the Denver neighborhood, or any given neighborhood in Denver. And Y represents, the number of entry-level jobs in that same neighborhood. So we have 1, 2, 7, 5, 9, and 3. So we got to do a lot of stuff with these little pieces of data. So first thing it's asking you to do is draw a scatter diagram, which all you have to do is just plot the X value and the corresponding Y value. Okay, that's pretty straightforward. Moving on down, these little pieces right here, you add up all your X values, add up all your Y values, you square each of the X values and add them up, square each of the Y values and add them up, sum all of your products of your X's and Y's, and this one down here, your correlation coefficient, that's a little tricky. Okay, you can use the correlation coefficient formula, or you can use a process that we're about to learn in just a second. Now, part C is asking you to find the least squares regression line. So y hat is equal to a plus bx, or bx plus a, whichever one you like. If you think about it, if you go back to your college algebra days, this right here is actually the slope-intercept form, okay? Because your slope, or your rate of change, is your b, and your y-intercept, or your vertical intercept, as some people like to call it, is your a value. So the problem is actually asking us to find what the least squares regression line is, because that's the key. Well, the first part is that we have to know our average, our x bar, which in this case you average up all of your x values divided by 6 in this case, and then average up all your y values and divide by 6, okay? Well, that's pretty straightforward. But the hard part is finding the correlation coefficient and the least squares regression line. All right, so we're going to use technology on this one because I can't show you by hand. It's just very time consuming and very cumbersome. But that's why we have technology, because technology makes our life easier. So what we're going to do, we're going to open up Microsoft Excel, which everybody has access to. Okay, it's free of charge for your school. And we're going to go back up to the top, and we're going to actually plot these, or we're going to put these data points in our Excel spreadsheet. All right, so we're going to make a column for X values, a column for your Y values, and for our X's, it's 15, 30, 50. So I can't really memorize too much. 15, 30, 50. Actually, I get a better idea. Let's try it like this. I am going to, I was doing some calculations earlier. I'm going to bring this over here to make our lives a little bit easier. All right, there we go. That way I don't have to switch back and forth between screens. Okay, so 15, 30, 50, 28, 50, and 25. That's all of our X values. Corresponding Y values are 1, 2, 7, 5, 9, and 3. All right, so now that we got all of our X's and our Y values in our Excel spreadsheet, what we're going to do, we're going to create a scatter diagram in Excel. So our scatter diagram should look something like we plotted earlier. So what we're going to do, we're going to highlight both columns with all the cells that we have data entries in. We're going to go to, let me kind of expand this real quick, Insert. And right up here, we're going to have our choice of graphs. All right. Now you want to go to the one where it says XY scatter and just create a normal scatter plot. All right. Now, ironically, this should look somewhat similar to what you have submitted just a second ago. See? Very similar shape. All right, pretty straightforward. Now, I am using the Mac version of Excel. In PC, it might be a little bit different, but the processes are pretty much the same. All right. The commands are the same. It's just how to get to the commands might be a tad bit different. All right. So we got our scatter plot. Now we have to figure out what our least squares regression line is, which ironically would also give us our correlation coefficient. So in order for us to figure this out, we go back to our Excel spreadsheet right here, and we hit a feature called Add Chart Element. And then we scroll down to where we see Trend Line, and you want to click on Linear. This equation, or this dotted line right here, is actually our least squares regression line, okay? And ironically, let me kind of go back here. It's roughly this right here, okay? So just a little heads up on that one. We've gotten a lot of pieces of this, this problem just by this graph, all right? Now, the key piece of information, we have to know what our least squares equation is, our least squares regression line. So this guy. So in order for us to do this, we want to click on the regression line that we just plotted, all right? And we want to hit Format Trend Line. All right, it's going to give us a whole lot of options. Now, what you want to do here is go to the bottom and hit Display Equation on Chart. And there is our equation right here. Now, our equation is in the form y equals mx plus b. Or, as it pertains to this problem, your a value is negative 2.067 and your b value is 0.199. Hey, what we have right here. All right. So Excel automatically puts it in mx plus b form. You just have to switch it around, okay, to make it fit the form that WebAssign wants. Now, to find your correlation coefficient, okay, we go back to our trend line, okay, and we go back to Format Trend Line, and then we hit the Display R squared value on the chart. So our R squared value is 0.8337. But the problem is we want our R value. So in order for us to figure out our R value, we have to take the square root of that teeny tiny equation right here to get R by itself. All right. So our R squared, and I'm just going to go down here and I'm going to let Excel do all the work. Our R squared is 0.8337. Okay. So I'm going to make that a little bit better. R squared is 0.8337. Then our R value, okay, our correlation coefficient, is just the square root of that. So in order to take the square root, to do a function in Excel, we have to hit the equal button, and then there's so many different ways to do this, okay? I like to do, nope, not that. I like to do equals SQRT, which is square root, and then open a parentheses. I'm going to highlight that cell right there because that's what I'm taking the square root of. And what do you know? The R value is 0.913, which is what we have right here. All right. So moving on down, oh, hey, what do you know? We need to find the R squared value. So we got the R squared value right here. All right. Now the explained and unexplained values. The explained values is basically you're taking the R squared value and changing it into a parentheses. I'm sorry, not a parenthesis. Changing it into a percentage. And the unexplained value is the opposite. So you want to take 100% minus, in this case, 83.4%, and that's where you get the 16.6%. All right. So in a nutshell, the explained value is you're taking the R squared value, changing it into a parentheses. Darn it. Changing it into a percentage. I don't know why I have parentheses on my mind. And then the unexplained value is taking 100% minus the explained value. Okay. Now, the last bit. For a neighborhood with X equals 3,900 jobs, how many are predicted to be entry-level jobs? Well, this is when we want to go back to our formula y equals 0.199x minus 2.067, our least squares regression formula. Okay? Now we want to take that equation and we want to plug in 39 in place of x. So I'm going to go ahead and type it in. Like I said, I'm going to let Excel do all the work. 0.199 times 39, where's the formula? Minus 2.067. Oh, and I need a equal sign because it's going to be doing a calculation. Okay. And Excel does not automatically read a parentheses as multiplication, so you do have to put a little multiplication symbol. So in this case, it would be Shift 8. And there we go. We would have 5.69400 jobs. Since it asks you to round to 2 decimal places, in this case, it would be 5.69, which is what we have right here. All right, so like I said, we want to let technology do most of the work for us, okay? And it's good to know it by hand, but a lot of times, we definitely want to make our lives easier, especially nowadays. So Excel can do a lot of this work for you. You just have to know the commands, you have to know the ins and outs of it. And what I've done in the past, I've always used Google to kind of search the commands and see what can work best for me, because you'd be surprised at how much Excel can do for statistics. You'd be very surprised. Okay, I'm still learning new functions as we go along. So in this case, let me know if you have any questions of any kind. I'm happy to help. But yeah, definitely work smarter and not harder, guys. Okay? Always happy to help. All right, guys? All right. See y'all later.